This is part 2 of the 6.03 review, voltaic cells. A voltaic cell converts chemical energy to electrical energy when an oxidation reaction takes place in one half cell and a reduction reaction takes place in the other half cell. A voltaic cell, also called a galvanic cell, consists of two half cells, each of which contain an electrolyte solution and a suspended electrode. An oxidation half reaction takes place at one half cell, or in other words, one part, and a reduction reaction takes place at the other half cell. The half cell at which the oxidation reaction takes place is called the anode. The half cell at which the reduction reaction takes place is called the cathode. The electrolyte solutions are connected by a salt bridge, and the electrical circuit is completed by a conductive wire connecting the electrodes. Objective: interpret a diagram of a voltaic cell, including identifying the anode and the cathode and the type of reaction taking place at each of these electrodes. Remember, voltaic cells. Oxidation is a loss of electrons and results in a more positive charge. Woohoo! Reduction is a gain of electrons and results in a more negative charge. Wah, wah. Oxidation does not always mean reaction with oxygen. In the more general sense of the term, it simply means the loss of electrons, although it can mean the gaining of oxygen. Describe a voltaic cell. A copper-zinc voltaic cell is shown below. All right, so we got our zinc half cell over here, our solid zinc. The electrons are going over to this side. So this tells you that this is what, the anode or the cathode. If the electrons started over here and went to the other side, where they started, it's negative, and they're attracted to the positive side, which is called the cathode. And then, of course, the salt bridge connecting it in order to keep the whole thing neutral. The flow of electrons is shown in the diagram. Identify the anode and cathode of the cell and write the overall reaction that occurs in the cell. All right. One of the electrodes consists of solid copper suspended in a solution of copper sulfate. The other electrode consists of solid zinc suspended in a solution of zinc sulfate. Electrons flow from the zinc electrode to the copper electrode. And go ahead and try writing the overall reaction if you're ready. If you're not sure yet, that's okay. The oxidation state of copper is 0 and in the solid copper and +2 in the copper sulfate solution. The oxidation state of zinc is 0 in the solid zinc and +2 in the zinc sulfate solution. If electrons are flowing from the zinc electrode to the copper electrode, the zinc electrode must be losing electrons to form the zinc 2+ ions. In addition, the copper +2 ions must be gaining electrons to form the solid copper. Therefore, zinc is being oxidized and copper is +2 is being reduced. Solve. Oxidation occurs at the anode and reduction occurs at the cathode. Therefore, the zinc electrode must be the anode, and we also do that because that's where the negative electron started. And the copper electrode must be the cathode. The reactions take place in the two half cells are shown below. The anode. We had the zinc. It yields zinc +2 plus the 2 electrons which detached. The cathode's the opposite. We have copper +2 plus 2 electrons yields, or they come together and they make copper with a 0 charge. Each of these reactions involves 2 electrons, so you can actually add the half reactions together like you do in math class, as written to obtain the overall reaction for the cell as shown below. All right, so we lined them up where the yield signs were. So we just took these 2 reactions, we put them on top of each other, we put a big plus sign, and we add going down. Copper +2, we have zinc +2 electrons, but look over here on the other side. We have 2 electrons on both sides, so they cancel off. And then our yield sign, we have our zinc +2 and our copper. And remember, our 2 electrons canceled, so this is our overall reaction. Tip, you can use an acronym to remember which half reaction occurs at which half cell. For example, consider the acronym INOX Red Hat. This acronym can help you remember that anode is where oxidation takes place and that red or reduction takes place at the cathode. All right. Which of these reactions could take place at the anode of a voltaic cell? Okay, so let's look at what's the difference. The first one, we're adding an electron, yields something else. Adding electrons yields something else. This one, something yields something with electrons. This one, something with electrons, yields something else. Can you find the pattern? Can you figure the answer out just from the pattern? Now, think of what this means. Anode, a negative. Okay, at the a negative, we have oxidation. Oxidation, okay, what does that mean? Oxidation means we want to get rid of electrons to be more positive. So, which one's getting rid of them? And the one that's getting rid of electrons is C. So we have H2 and it breaks apart. Now it's H2 plus, so it's more positive. Woohoo! And it got rid of some of those electrons. Now if you notice, it's not H plus 2, but there's two H's, each with which lost one electron. All right, number 2, the following half reactions occur in a voltaic cell. Aluminum yields aluminum plus 3 electrons. Tin plus 2 adds on 2 electrons to become tin with a 0 charge. Which reaction happens at the cathode, which is the anode? Explain your answer. Anode, a negative. Anode, oxidation. Oxidation means get rid of electrons, mean become more positive. All right, which one's becoming more positive? Is the aluminum becoming more positive, or is the tin becoming more positive? Well, the tin is going from plus 2 to 0. That's going down. That's being reduced. Reduction happens at the cathode. Aluminum is becoming more positive. Woo! And more positive is your what? It is your oxidation. Sorry, I forgot to say hit pause on these to do them yourself. I hope you did. If not, try them again later. Make sure you can do it without me explaining it. Number 3, which is more likely to be produced at the anode of a voltaic cell? Cadmium plus 2 or chlorine minus 1? Explain your answer. So hit pause, think it over. Oxidation occurs at the anode. During oxidation, a species loses electrons. Cadmium plus 2 could be produced by the oxidation of either cadmium 0 or cadmium plus. For chlorine to form through oxidation, it would have to form from a species with more negative charge, such as chlorine minus 2. You might guess that removing a second electron from an already negative ion might take a lot of energy. In fact, chlorine minus 2 and other highly negative charged chlorine atoms are extremely unstable and generally do not occur in nature. Therefore, cadmium plus 2 is more likely to form at the anode than chlorine minus 1 is. All right, that's it. If you need to review some more, make sure you do. Otherwise, you're ready for the quiz. Good luck. And as always, if you need help, come see me.